What's up everyone, it's Red Saber here from Saber C++, and today we're adding a graphics engine to our Tetris game so we can actually play it on our MicroCade. Let's get started. First, I'll create an int brick size at the top of the program and I'll set it to 3. This means that each block will be 3 pixels by 3 pixels. We're going to need two functions, one of which will render the frame of the field and the other of which will render everything inside it. Because the frame only needs to be created at the start of the game, but the field needs to be re-rendered every time something changes. At the bottom of the program, let's create a void render frame. I'll start by creating an int x equals 0 and an int y equals 0. Then I'm going to create a for loop with an int p going from 0 to less than or equal to field width times field height. If x mod field width is equal to field width minus 1, then we're at the right edge. So y plus equals brick size will allow us to move down by 1 brick. Outside of that, we'll want to set x equals p mod field width. Then we'll check if field p is equal to 9, so if this is an edge or bottom, where we should be rendering the frame at, and if it is, we'll run aboy.fillRect x times brick size plus 46, y, brick size, white. So we'll fill in a rectangle from the correct x position, which we get by counting the number of bricks, x times brick size, that we should be at, plus 46 because we're offsetting the field 46 pixels from the left side of the screen so that it's in the center. Then, of course, we're doing it at the y position, and we're setting the size of it to be brick size tall and brick size wide. At the bottom of the function, let's run aboy.display to output this to the screen. Then we can call renderFrame at the end of the setup function and at the end of the loop function in the if statement where the player restarts the game. Let's create the void render below the renderFrame function. Now, the structure of this function will be the same, so let's copy the contents of renderFrame into render so we can modify it. Instead of checking if field p is equal to 9, we'll create a switch statement based on output p so that we can check all of the different cases for the 7 tetrominos, the equal signs for a line about to be cleared, and empty space. So in case space, we'll run aboy.fillRect x times brick size plus 46, y, brick size, black, to fill the empty square with black. In case A, we'll first run aboy.fillRect x times brick size plus 46, y, brick size, black, to fill the square with black. And then we'll run aboy.drawRect x times brick size plus 46, y, brick size, white. So we have a white rectangle with a black center, which will help the player differentiate this from the solid white walls. I'll copy case A for the other 6 pieces, changing the letter, the proper one, but still filling in a white rectangle with a black center. The last thing to do is case equals. First, I'll run aboy.fillRect, just like we did with the others, to fill the square with black. And then I'll run aboy.drawLine x times brick size plus 46, y plus brick size divided by 2, x times brick size plus 46, y plus brick size divided by 2, white. This will draw a line through the center of the square so we get something like this when we fill up a line before it's deleted. Then we can call this function instead of output field at the end of the while loop and when we want to render the field before removing a line. Let's try it out. As you can see, we're now able to play the game on our MicroCade and it's much more playable than when we were doing it in the serial monitor. However, we can't see our score, there's no title screen, and some sound would be really nice. So let's do all of that in our next video to finish up the game. I'll put that video there on the right as soon as it's available, and you can check out my channel on the left for lots more tutorials about Arduino and the MicroCade.